In this module, I am going to discuss about black body radiation in the form of MCQs. Question number 1. A black body is at a temperature 303 Kelvin. The energy emitted per second per square meter from the black body is proportional to option A 300 to the power 3, option B 300, option C 303 to the power 4, option D 303 to the power 2. According to Stephen's law, the radiant energy emitted by a perfectly black body per unit area per second is directly proportional to the fourth power of its absolute temperature. Based on Stephen's law, we can write energy emitted per second per square meter by the black body at 303 Kelvin is proportional to 303 to the power 4. The correct answer is option C, 303 to the power 4. Question number 2. A black surface absorbs dash as compared to a white surface under identical conditions. Option A, same heat. Option B, negligible heat. Option C, more heat. Option D, lesser heat. The name black body is given because it absorbs all colors of light. Black body is an idealized physical body. It absorbs all incident electromagnetic radiations regardless of frequency or angle of incidence. The black surface absorbs all the radiations more easily than any surface as its absorptivity is 1. Black surface absorbs more heat than any other surface under identical conditions. Hence, the correct answer, option C, more heat. Third question. The temperature of two perfect black bodies A and B are 400 Kelvin and 200 Kelvin respectively. If the surface area of A is twice that of B, the ratio of total power emitted by A to that by B is option A 4, option B 2, option C 32, option D 16. According to Stephen's law, the ratio of energy densities E1 upon E2 is equal to T1 upon T2 the whole power 4. When we substitute the values for T1 and T2 in this expression, we obtain 16. The power of the first body is equal to energy density into 2 times of area. The power of the second body is equal to energy density into area. The power ratio is equal to E1 into 2A upon E2 into A. We obtain 32. Hence, the correct answer, option C, 32. Question number 4. Every object emits radiation. The radiation energy is proportional to what power of temperature? Option A, temperature. Option B, T to the power 2. Option C, T to the power 3. Option D, T to the power 4. In the world, all objects emit radiation if they have a temperature greater than absolute zero, and this radiation energy is proportional to fourth power of temperature. Hence, the correct answer option D, T to the power 4. Question number 5. A black body is maintained at 27 degrees Celsius and 927 degrees Celsius. The ratio of radiation emitted will be option A 1:4, option B 1:16, option C 1:64, option D 1:256. In the question, temperature is given in Celsius scale. It should be converted into Kelvin scale before we solve the problem. We know Kelvin temperature is equal to 273 plus degree Celsius temperature. To convert 27 degrees Celsius into degree Kelvin, we have to add 273 with 27 degrees Celsius. When we add, we obtain 300 Kelvin. Hence, T1 is equal to 300 Kelvin. Similarly, 927 degrees Celsius to be converted into Kelvin scale. So, we have to add 273. We obtain 1200 Kelvin. Hence, T2 is equal to 1200 Kelvin. When we substitute T1 and T2 values in the expression, we obtain 1:256. Hence, the correct answer option D, 1:256. Question number 6. Good absorber of heat is good radiator of heat also is option A, Stephen's law, option B, Kirchhoff's law, option C, Planck's law, option D, Wien's law. The fact that good absorbers of heat are good emitters, it is based on Kirchhoff's radiation law. It states that at a given temperature, the coefficient of absorption of a body is equal to its coefficient of emission. A black body is a good example of a good absorber of heat as well as a good emitter of heat. The ease with which a black body can absorb a photon is the reverse process of emitting the one. This entire cycle takes place because of the number of transitions that are associated with the electromagnetic field. Hence, the correct answer option B, Kirchhoff's law. Question number 7. As the wavelength increases, the energy emitted from the black body radiation will dash first and then dash. Option A, increase, become constant. Option B, increase, decreases. Option C, decrease, increases. Option D, none of the above. Black body neither reflect nor transmit radiation. but it absorbs the whole of the heat radiation. In the energy distribution curve of black body radiation, we can see as the wavelength increases, the energy emitted increases and it reaches the maximum height. After this point, it started decreasing gradually. So, when wavelength increases, the energy emitted from the black body radiation will increase first and then decreases. Hence, the correct answer is option B. Question number 8. A black body can absorb radiations of option A, higher wavelength only, option B, lower wavelength only, option C, intermediate wavelength only, option D, all wavelength. A black body is an idealized physical body. It absorbs all incident electromagnetic radiation of any wavelength regardless of frequency or angle of incidence. Hence, the correct answer option D. Question number 9. The following is and or laws of black body radiation. Option A, Planck's law. Option B, Stephen-Boltzmann's law. Option C, both of the above. Option D, none of the above. The laws of black body radiation governed by Planck's law of black body radiation, Wien's displacement law and Stephen-Boltzmann's law. Planck's law of black body radiation describes the spectral density of electromagnetic radiation emitted by a black body in thermal equilibrium at a given temperature when there is no net flow of matter and energy between the body and its environment. Wien displacement law states that the black body radiation curve for different temperature peaks at a wavelength that is inversely proportional to the temperature. Stephen-Boltzmann's law describes the power radiated per unit time from a black body in terms of its temperature. Hence, the correct answer option C, both of the above, Planck's law and Stephen-Boltzmann's law. Question number 10. A polished metal plate has a rough and black spot. It is heated to 1400 Kelvin and brought immediately in a dark room. Which of the following is true? Option A, the spot will appear brighter than the plate. Option B, the spot will appear darkened than the plate. Option C, the spot and plate will appear equally bright. Option D, the spot and the plate will not be visible in the dark room. Since 1400 Kelvin temperature is much higher temperature compared to the room temperature, so both the polished metal plate and the rough black spot will emit radiation at a higher rate. Since the absorptive power of the rough black spot is more compared to the absorptive power of the polished metal plate, so according to Kirchhoff's law, the emissive power of the black spot will also be more compared to the polished metal surface. So, the rough black spot will emit more radiation compared to the polished surface. So, the spot will appear brighter than the plate. Hence, option A, the spot will appear brighter than the plate is the right answer. Question number 11. A man with dark skin in comparison with a man with white skin will experience option A, less heat and less cold. Option B, less heat and more cold. Option C, more heat and less cold. Option D, more heat and more cold. A black body absorbs all the radiation falling on it. A perfect black body absorbing 100% of the radiation. Doing so absorbs heat and becomes hot. Whereas white body reflects all the radiation falling on it. A perfect white body reflects 100% of the radiation. Doing so, it becomes cool. Dark color absorbs more heat than of light color objects. An object near to black absorbs almost all kind of incoming visible radiations. Similarly, white color reflects all incoming radiation. Hence, it becomes cool. The correct answer is option C, more heat and less cold. Question number 12. Question number 12. Temperature of a black body increase from 300 Kelvin to 600 Kelvin. The energy emission rate in the process will become option A 2 times, option B 4 times, option C 8 times, option D 16 times. The question, temperature values are given. T1 is equal to 300 Kelvin, T2 is equal to 600 Kelvin. According to Stephen Boltzmann's law, energy density is directly proportional to the fourth power of temperature. When we substitute the values of temperature separately in the expression of Stephen Boltzmann's law, we obtain E2 is equal to 16 times E1. So, energy emission rate in the process will become 16 times. Hence, the correct answer option D 16 times. Question number 13. A black body has maximum wavelength at 2000 Kelvin. Its corresponding wavelength at 3000 Kelvin will be option A 2 lambda upon 3, option B 3 lambda upon 2, option C 81 upon 16 lambda, option D 16 upon 81 lambda. Wien's law states that the blackbody radiation curve for different temperature peaks at a wavelength is inversely proportional to the temperature. The given maximum wavelength at T1 is equal to 2000 Kelvin. We have to find wavelength at 3000 Kelvin. When we put these values in expression 1, we obtain lambda 2 is equal to 2 lambda upon 3. Hence, the correct answer option A 2 lambda upon 3.